Okay, we're going to start on 2.7. Um, so this is all about how to combine two functions. We'll call them f of x and g of x. And the first part, what we're going to use just arithmetic operations. To combine the functions. And the question will be, the primary question is, what is the domain? What is the domain in each situation? What is the domain? Okay, so the first way to combine is through addition or subtraction. And I write them, this is effectively two methods, either plus or minus. And in the second column, we'll find the domain. So the domain here of either of these, and I'm just going to write it as f plus or minus g, well, whatever x value you have, it's got to be able to be plugged into f. It's also going to need to go into g. So it's got to be what's going to be able to be plugged into both. So let's give the domains some names. Let's call the domain of f a, the set A. And let's call the domain of g the set of numbers b. Then if it's going to be what's in common, then it's going to be what's in what's called the intersection, A intersection B. And this basically means what's in common in both A and B. Okay, because it's got to be in whatever the number is, it's got to be in the domain of f, but it's also got to be able to be plugged into g, like I was stating. So that's exactly in mathematics what we call the intersection. And the same is true if we multiply two functions. So we could take the product of these two functions, and then we would say, okay, well, what is the domain then? What x values? Let me just write it as f for short. Let me just shorten this a little bit. F dot g, that just means f times g. Well, it's the same story actually, because x has to be able to be plugged into there. X also has to be able to go into g. So it's again what's in common between both A and B, because you have to be able to be plugged into both of them. So you get the intersection of the domain of f and the domain of g. And division is the only one where things change a little bit. Well, it's certainly true that you have to be able to be plugged into f, and you have to be able to plug the x value into g. But also note here that g of x can't be 0. So let me just write that in words, I guess. G of x can't be 0. So that's the additional condition for C. So the domain of f over g, this is, well, it's A intersection B with the additional condition, with the additional condition, that g of x is not 0. So another way to write this is, I'll write it in what's called set theoretic notation. It's all x, and this little line means such that, all x such that x is in the domain of f, and x is in the domain of G, and g of x is not 0. This is kind of the set theoretic way to write it. So essentially it's what's in common, but for the division, you have this additional condition. So let's do an example. So let's let f of x be 1 over 4x minus 16, and g of x is the square root of x minus 2. Now, first off, you want to find, before we take the sums and the products and all of that, let's first find the domain of f itself. Well, all that is required is the denominator not be 0, so it's all x, such that 4x minus 16 is not equal to 0. So the only value you're not allowed, you can check that if x was 4, you'd have 16 minus 16, and that would equal 0. So essentially you have x not equal to 4. Here, in a square root function, you need x minus 2 to be at least 0, because you can't take a square root of a negative number. So that means x has to be at least 2. So this is your defining condition for your set A. This is your defining condition for your set B. If you wanted to write A specifically, in interval notation, you'd have everything below 4 as well as everything above 4. And B would be 2 to positive infinity. Well, sometimes it's easier to just read it off. X has to be at least 2, and x can't be 4. So essentially what do we have visually? We have 2 to positive infinity, and then at 4 here, we have to create a little gap. So this pictorially right here, this is the intersection. This is A intersection B. Right? B just says you got to be above 2. This says you can't be 4. So that means you got to be above 2 and not 4. Hence, A intersection B in interval notation. This is including 2 up to 4, not with the open parentheses here because we can't include 4, as well as everything above 4. So this is the domain of f plus g, the domain of f minus g. So and we'll write down what those are in a second, as well as the domain of f times g, where, so f of x plus g of x, what is this? This is 1 over 4x minus 16 plus the square root of x minus 2. F of x minus g of x is 1 over 4x minus 16 minus the square root of x minus 2. And then the product here is the product of 1 over 4x minus 16 times the square root of x minus 2, which is the square root of x minus 2 divided by 4x minus 16. So these are the functions explicitly right here, where their domains, they all have the same domain, which is the intersection of the domain of f with the domain of g, and that turns out to be exactly this guy. Okay, the last part of this is to compute the domain of f of x divided by g of x. Well, let's first just write what that is. That's 1 over 4x minus 16 divided by the square root of x minus 2. So this says I have 1 over 4x minus 16 times 1 over, because remember the square root of x minus 2, that's the same as dividing by 1 here. And so dividing by something is the same as multiplying by the reciprocal, or the flip of that. So I get 1 over quantity 4x minus 16 times the square root of x minus 2. So this is the expression for, let me just write it one more time here, f over g of x. If you think of it as a sort of writing it as a single function, this is equal to 1 over 4x minus 16 quantity times x minus 2. Now the question is, what is the domain of this? So the domain of f over g, well, what did we say? Well, it's exactly what we had earlier, and we need the requirement that g of x is not 0. So we need, what was g of x? So we need this to be true, and square root of x minus 2 can't be 0. Well, when is this 0? Square root of x minus 2 equals 0 when x equals 2, right? You could square both sides if you'd like to and do this algebraically. And get x minus 2 is 0, so you get x equals 2. So when x equals 2, well, that's a number that we don't want, right? We don't want 2 because that'll make the denominator 0. What was A intersection B? This was 2 to 4, as well as 4 to infinity. So all we have to do now is delete this 2 to get our final answer, because that's what we want to get rid of. So we can't have here, now we can't have x equaling 2 because that's what makes g of x equal to 0. We don't want that, so we have to get rid of that. So our final domain here, domain of f over g, this is actually the open interval 2 to 4, union 4 to infinity. Okay, so that was one example. I'm going to leave you here with an exercise to try, which is, suppose f of x is 1 over x squared minus 4, and g of x is x over the square root of x plus 1. So find the domain of f, call that A, the domain of g, we'll call that B, and then find the domain of all of the arithmetic combinations. So the domain of f plus or minus g, the domain of f times g, the domain of f over g. And write down the expressions for each of these. Write down expressions for f plus and minus g of x, f times g of x, and f over g of x. Okay, we'll stop here for now, and we will pick up there next.